Well, I've received my first request, so this video is going to be about gears. Now, it may look complicated at first, but I'm going to take you through it, and by the end you should have a good understanding of how gears work. So here we have our piston cylinder device. This is your engine, and as this piston moves up and down, it rotates this crankshaft. This crankshaft is connected via a gear to the transmission. Now, for example purposes, I've come up with gears for this drivetrain right here. So our driving gear, let's say, has 10 teeth on it. This gear is connected to a gear in the transmission with 30 teeth. So what that means is every time this crankshaft right here rotates 3 times, the transmission itself will rotate only once. And that's because of this gear ratio. So it's smaller, it's going to rotate 1 full revolution of this, and this is only going to rotate 1/3 of the way. Now as you change gears, alright, let's say we shift and our engine is now in 2nd gear and these 2 gears are connected. Well, then every 2 revolutions of this gear, and you're going to have 1 revolution of the transmission, because there's 20 teeth on this, 10 teeth in here. The gear ratio is the driven gear over the driving gear. This right here is your driving gear, so it's got 10 teeth. This here is your driven gear. It's got 20 teeth. So 20 divided by 10, 2:1 is your gear ratio. Alright, so this here is rotating, and this is your transmission, and finally it gets output to your differential, and these are going to be your driving wheels. Now these driving wheels also have a gear ratio. For this example, I've just said it's 3.5:1. What that means is every time your transmission rotates once, you're going to have, so it's going to take 3.5 revolutions of your transmission for your tire to go around 1 time. Now, you got to look at the big picture once again. So let's say we're in 1st gear with a gear ratio of 3:1. There's 3 times as many teeth on this gear as there are the driving gear. So we've got a gear ratio of 3:1. Now our differential, now that doesn't change. The differential is just set. So that's going to be 3.5:1. Every rotation of your tire requires 3.5 revolutions of your transmission. Now, if you multiply these together, you get 10.5. What that means is every rotation of your crankshaft in your engine will give you about 1/10 of a revolution. It's going to take 10.5 revolutions of your crankshaft from your engine to get the tire to rotate 1 time. Alright, so that's basically how gears work. And a question came up, well, why is your maximum torque in 1st gear? Well, this is an equation based, and I'm going to help you understand this. You've got engine torque, and that's just a number of the max torque, or the torque at a certain RPM that your engine produces. Say 50 pound-feet at 1,000 RPM. Doesn't really matter. Your engine torque varies based on the RPM, and that is it. It cannot vary based on what gear you're in. The transmission output torque, the torque your transmission is putting on your rear driving wheels, can change. And that's this equation right here. Engine torque times gear ratio equals the transmission output torque. So as you can see, if you increase this gear ratio, let's say a gear ratio of 3, you've got your engine torque times 3, and that's your transmission output torque. That's the torque that your transmission is putting out onto your wheels. Now, if you have a lower gear ratio, you're in 2nd gear, then you're going to have a 2 here instead of a 3. So you can see that your transmission output torque is going to be slightly less. That's what people are saying when they say you get the most torque in 1st gear and therefore the greatest acceleration. If you think about it, when you're riding a bike, it's easiest to start pedaling in 1st gear, and then once you're up to speed, you can switch into the higher gears. Well, it's the same way with a car, and that's why. It's because of this gear ratio. It's a lot easier to spin this bigger gear a small amount, rather than a small gear twice all the way around, because that means you're going to have to rotate your tires twice all the way around. All right, so another question is, why can't we just stay in first gear if first gear has the most torque, which it does that it's putting out on the tires? Well, that's another good question, and the reason is because of a red line. All cars have a red line. For our model, I'm going to say 6,000. Now what this number represents is the maximum speed that your engine can rotate this crankshaft at without things failing. The components are going to withstand it. Things like friction, heat, and the strength of these materials being used are the main factors in coming up with this red line. Now you're saying, okay, so I have a red line, why can't I still just stay in first gear and go up to 6,000? Well, your red line is going to limit your speed based on what gear you're in, and I'm going to try and explain that to you mathematically here. Okay, so we're in first gear. This is gonna calculate our top speed, first gear, top speed. Okay, so we're in first gear. We've got 30 teeth to 10, so a gear ratio of 3 to 1, and our differential is 3.5 to 1. All right, well, there's another thing we have to calculate. We've got the tire here in the back. Let's say your tire has a total diameter of 24 inches. So you've got 24 inches times 3.14, and that is going to give you about 75.36. Now this distance right here is in inches, and that's going to be the distance you travel with 10.5 revolutions of your crankshaft. So every 10.5 revolutions of your crankshaft, you've got 1 revolution of the tire. The tire's circumference is 75 inches. So that's how far you go with 10.5 revolutions of your crankshaft. All right, so now we want to calculate the engine speed and how this plays in. So we've got 6,000 RPMs. Now we're going to multiply that. Revolutions per minute is what RPMs stand for. So we're going to multiply that by 60. That way we can get revolutions per hour. So we will now have, this is going to be 360,000 revolutions per hour. All right, from here we want to calculate how fast this is getting you. So we're going to want to divide by 10.5. That's going to be your gear ratio. And then we're going to multiply this by 75.36. And this number, so you're going to have a revolution per hour over your gear ratio times the distance. This is going to give you a speed in, it's going to be, let's see, you're going to have distance per hour, it's going to be inches per hour, right? So once you divide all this out, you're going to have this in inches per hour. That comes out to 2,583,770. That's going to be inches in an hour. All right, so there's 5,280 feet in a mile. There's 12 inches in a foot. So you're going to divide this 2,580,000 inches per hour by the amount of inches in a mile. This is going to give you miles an hour. Now once you take this 2,583,000 divided by, that's going to be 63,360, this multiplied together, and that is going to give you a total of 40.8 miles per hour. Now this is the important number. This is why we're doing this math here. And if you didn't really understand this, that's fine, but just look with me here. Now your first speed is your first gear top speed is limited by your red line, 6,000 RPM. Now at 6,000 RPM, the maximum speed that your crankshaft can rotate, you can only obtain 40.8 miles per hour. Now your car's not any good if that's your max speed. You want to get a little faster than that. That's why we have these other gears. By reducing this number right here, for instance, we've got a 3-to-1 times 3.5. Well, if we had a 2-to-1, 2 times 3.5, this would be replaced with a 7. This will make this a greater number, making this speed right here a greater number. I've gone ahead and done the math for all of these, so I'm just going to go ahead and tell you which, for these gear ratios that I've got here, 3-to-1, 2-to-1, 1.5, 1-to-1, 0.75, and 0.5-to-1, with a differential gear ratio of 3.5-to-1, your max speeds are going to be 41, 61, and these are in miles per hour, 82, fourth gear is going to put you at 122, fifth gear is going to be 163, and sixth gear will limit you at 245. Now, I know these seem a little unreasonable. Not many cars are going to reach 245 miles per hour, but that's not what this is saying it can do. This is saying your transmission can go up to a speed of 245 miles per hour if you're rotating at 6,000 RPMs in sixth gear. Now, you're going to have air resistances and things like that, friction losses, and you're not actually going to be able to obtain 245 in most vehicles. But you want the possibility to be there, so you design a transmission that can be fuel efficient at higher speeds. It'll knock down to lower RPMs, and that's why they do it. So hopefully this has provided you with an understanding of how gears work. You're going to change between each of these depending on your speed so that you can reach higher speeds and increase fuel economy. You don't want to stay in first at 40 miles an hour just because you can, because you're going to be wasting a lot of fuel at 6,000 RPMs. Whereas if you go into third or fourth or fifth when you're going 40 miles an hour, you can drop down to a much lower RPM and you'll save fuel. And I hope that explains your question. Thank you.